Alright, let's now understand another very important concept, the hexadecimal numeric system. So let's now take some time and try to understand these hexadecimal numbers. Now this numeric system is a base 16 numeric system, and you should have some ideas about what this 16 means. Again, if we go back to our formula in hexadecimal numbers, we have to take each character and multiply it by 16 to the power of its index, and also we only use 16 characters or 16 symbols to represent our numbers. Now you might be thinking, why in the world do we have to care about this? Well, we know that we have to care about binary numbers because computers work with binary. The most basic thing in the computers is binary. If you try to assemble a CPU yourself, if you try to build a motherboard, a computer yourself, you're going to deal with binary a lot. You have to build your logic on top of binary. If you take a look at a file that you have on your computer, the most basic thing in that file is zeros and ones. So the unit of each file is just zeros and ones. So we already have established that, and we already know that as software engineers, it's very important to understand these binary numbers. But why do we have to care about hexadecimal numbers? Why do we have to use another numeric system beside binary or decimal? Now, I just want to say this right now, that the main reason that we're learning about this numeric system, this base 16 numeric system, is because conversion between hexadecimal and binary is insanely simple. It's very easy to do that. It's just some replacing. You only need to have a table that has 15 rows. You can even print it down, and then at any point that you want to convert back and forth between binary and hexadecimal, it's super easy. And there is something very neat about it, that each 4 bits that you pick, there is one hexadecimal character and only one hexadecimal character that could represent that exact same number. So any 4 bits that you pick, there's exactly one hexadecimal character that you can use instead of that 4 bits. So now, if you want to take a look at the contents of a file that has 4,000 bits in it, if you want to take a look at the contents of that file and see it in zeros and ones, see what exactly that file is, well, you're going to see 4,000 zeros and ones. But if you want to display that in hexadecimal, you're going to see only 1,000 characters. And at each point that you want to see the binary, you just do a very simple replacing. If you want to take a look at the content of your memory, or if you want to take a look at the binary, the raw binary data of a file, which is something that you would probably do a lot in your career, if you want to do something like that, the content of the memory that you're going to see, well, it's in zeros and ones, but in computers, we have this as a convention. Instead of seeing zeros and ones, which is going to be a lot of characters, we're going to see hexadecimal. So we're going to see hexadecimal a lot as software engineers. All right, having said that, let's now try to understand these numbers. Now, here I have one hexadecimal number on my screen. It's 456. Now, we haven't yet talked about the symbols that we have in hexadecimal, but it's very similar to decimal, but now we've got a few more characters, a few letters. And well, because a hexadecimal number really looks similar to decimal, in this example, we can see that it's 456, and we have no way to know if it's decimal or if it's hexadecimal or anything else. Now, in hexadecimal, as a convention, when we want to display hexadecimal numbers, we add one indicator before that number, okay? So you might see this a lot. If you want to take a look at the content of your memory, you will see the addresses displayed with something like this. In the terminal, if you want to deal with hexadecimal, you're going to see these indicators a lot. Now, it's important to know that this is not part of the number, and this thing that we have here is nothing but an indicator. Okay, so this is just an indicator so that we say that this number that we have is a hexadecimal number, and usually we use 0x. But we might use other symbols such as a sharp sign, and we're going to take a look at a few examples later in the video, but I just want you to know right now that we usually don't display hexadecimal numbers as they are. We just add some kind of a symbol behind them so that we know that we are now dealing with a hexadecimal number. If you want to display a number in binary, it's pretty straightforward. You can just say that it's binary right off the bat because it's just zeros and ones. And if it's decimal, well, we all are used to a decimal, so we don't really have to say that this number is decimal, right? But now when it comes to hexadecimal, because it could look really similar to decimal, we use one of these indicators. All right, so let's now see what this number really is. 456 in hexadecimal. What does it mean in decimal, in the numeric system that we all use, okay? So again, we have to go back to that concept that we talked about. We have to take each character and then multiply it by now 16 to the power of its index, because it's a base 16 number, all right? Hexadecimal is a base 16 numeric system. So we're going to take 6, we're going to multiply it by 16, now to the power of 0. In this case, it's 6, because any number to the power of 0 is 1, so 6 times 1 is 6. And the indexes that we use, again, in all these numeric systems, we say that the rightmost character, the rightmost number, gets index number 0, and if you move to the left side, by each number, you just add 1 to that index, okay? So now we're going to take the second character, which is 5. Now we'll have to multiply this by 16 to the power of 1, and the result is 80. Now likewise, we're going to take 4 times 16 to the power of 2, and the result is 1024. And again, just like before, now that we have these numbers, what we're going to do is that we're going to take all these numbers and we're going to add them together to end up with a number that we are all used to, a decimal number. In this case, that decimal number is 1110. Okay. Again, it's important to know that these two numbers are representing the exact same thing. If I say that right now a store has 1110 pineapples, it's the same exact thing if I say that that store has 0x456 pineapples. Again, the number, the amount is the same thing. It's just two different ways to represent the exact same thing, all right? All right, so hexadecimal is base 16, so we use only 16 characters or 16 symbols to represent our numbers. Let's take a look at these symbols. All right, so let's just lay all these numbers right now on our screen. Again, each one of them, we could regard them as a symbol or as a number or as a character, it doesn't matter. But these things, these items that we have, actually are a different number. Well, the first 10 are just the same number in decimal, but these letters that we have, A, B, C, D, E, F, well, they are again just numbers. And here we can take a look at all these numbers. So if I say 5 in hexadecimal, it's the same thing as 5 in decimal, but now instead of just using 10, we use A. Instead of just using 11, we use B, and then C, D, E, and F. Okay, so this numeric system, we use a few more characters starting from A to F, and these are the actual numbers that these numbers represent. So if I say that in hexadecimal I have B number of apples, it's the same thing if I say that I have 11 apples, okay? So we just use these symbols to make our job easier. Now let's take one hexadecimal number. Let's just have one example. In this case, FA3C. Now these symbols A, B, C, D, E, and F, they could be either lowercase or uppercase. We don't care about that. It's just not important. So hexadecimal numbers are case insensitive. Now, if we want to calculate this number, again, just like before, we take each character and we multiply it by 16 to the power of its index. But now the first character that we have is C. But what C really is? What is C in decimal? Now, if you take a look here at this row that we have at the top, C is 12. So in our formula, we use 12 times 16. Same thing with 3. Now 3 is the exact same number in decimal, so we just use 3 times that, and then we take A. Now think about it for a second. What number should we now use for the third one? What A is? Well, if we take a look here, A is 10. So we're going to take 10 and multiply it by 16 to the power of 2, and this is the result. And now let's take our last number, our last character in the number, which is F. So we're going to take 15, because if we take a look here, F is 15. So 15 times 16 to the power of 3, which is this number. All right, and then just like before, we take all these numbers and we add them all together, and this is the result that we're going to have, 64,060. So if you take a look here, now this FA3C might be confusing to you, but when you get used to hexadecimal, it's actually much simpler in a lot of cases to take a look at hexadecimal compared to maybe decimal or binary. Well, if we are dealing with computers, all right? outside of computing, not really. I mean, it would be really weird to try to count in hexadecimal, but in computers, it's much simpler to take a look at hexadecimal. For example, location of the memory or some of the IP addresses and many other things. It's just much simpler to take a look at hexadecimal compared to decimal because you can easily, again, convert that to binary. And we're going to see that in just a minute in this video. But just for a comparison, let's say that I have this hexadecimal number. So a few Fs. Now, how many characters do I use here? If you count all these Fs, well, that's only 6 characters. Now, if you want to display that in decimal, this would be the number. So if you open up your calculator, your programming calculator, and we're going to do that in just a minute, and calculate this number, this is what we're going to end up with. Now, how many characters do we use here? Now, if you count the numbers, that is 8 characters. And in binary, well, it's going to look much more crazy. And if you just convert this hexadecimal number to binary, this is the number that you're going to end up with. And it is 24 characters. So if you take a look here, we condensed this huge number to only a few characters by just using hexadecimal, which is much simpler. This is going to make our job much easier moving forward in dealing with maybe memory, in dealing with the files, and in many other cases. It's going to be much simpler to deal with this number compared to this gigantic binary number right here. If you want to give an instruction to your CPU to maybe take this data and then maybe send it somewhere else, it's much easier to type this number compared to typing this 24 characters. And this is kind of a simple example. It's all Fs, so we're filling all the bits with 1, but you can imagine that here we could have much more complicated combinations. We could have maybe 1 and then 0, 0, 1, 0, 0, 1, 1, 1, and so you get the idea. So hexadecimal is going to help us a lot with this whole process. Alright, now let's see how exactly using hexadecimal will help us to deal with binary. Now, as we said before, it's really easy to convert back and forth between these two. And the very neat thing about hexadecimal is that each hexadecimal character is exactly 4 bits. So each 4 bits, if I give you a binary data, maybe the data of a file, or if you just take a look at the content of your memory, of your RAM, you're going to see just something like this, zeros and ones. But you can represent each one of the 4 bits using only 1 hexadecimal character, which is really nice and really neat, and it's going to help us be able to figure out what's going on in that file or in our memory much better. So here, if you take this binary number, this data, so here we have 32 numbers, so 32 bits. Now, if you take a look at the content of a file again using a binary viewer, this is probably what you would see. Now, in this case, it's only 32 bits. So if you have a file that has only 4 characters, this would be what you would see. Well, not the exact same combination, but you get the idea. But you can represent each one of the 4 bits using only 1 hexadecimal character. So if you put 0101 in your programming calculator, which is something that we're going to see later on in the video, you're going to get number 5. Same for this one, this one, this one, and so forth. So now, if you want to view the binary contents of a file or in your memory, instead of seeing this whole gigantic number, which is 32 numbers, 32 zeros and ones, you would see something pretty neat just like this. So instead of seeing this whole thing, you would only see 557D and 5F01. And this is much easier to take a look at compared to this one. Now again, the neat thing here is that each character is 4 bits and you can easily convert back and forth. You don't need to do any kind of sort of math. You don't really need to do any crazy calculations. It's just something pretty straightforward. In fact, there's this table that says the binary number for each hexadecimal character. And just by having this table, it can easily convert between binary and hexadecimal. So if I give you 5 in hexadecimal, you just take a look at this table. This is 5 in hexadecimal, and you just put down instead 0101, and that's it. So if I give you a huge hexadecimal number, at each point you can figure out exactly what you have there just by taking a look at this table and doing some replacing. Now, you don't really need this. If you're just starting, it could be really good to have a table like this. It'll just make your job much easier. But as you move forward, something else that you can do is to easily convert each character to maybe a decimal, and then from decimal to binary, or you can just learn how to count in binary and do it that way. Whatever you want to do, at one point you will get to a point where you can just take a look at a hexadecimal character and be able to easily say what's the binary for that number, or you could just have this table. But as you can see here, this is something that will make our job much easier, because when you want to deal with your memory, you want to take a look at what you have in your memory, you're going to see hexadecimal, and at each point that you want, for example, the 0 and 1 or anything else, you can easily convert them to a binary just by having this table. Again, you don't have to do any crazy calculations, you don't really have to do anything, it's just this table, and it's just a matter of replacing stuff. Now, I also want to point out that these things that we're learning right now, this hexadecimal and binary, and also many other concepts that we're going to explore in this course, these are not advanced concepts, okay? This is not something that you're supposed to learn about after 5-10 years of programming or something. This is something that you have to learn the sooner the better. Maybe in your first year, after 1 year or a few months of programming, this is something that you have to learn. These concepts are the things that you have to get into and really learn about them. If you go to study computer science at any good university, at least here in North America, and I know that that's the case for a lot of other places, in the first year, in the first semester actually, in the very first few weeks of you being in the school, you're going to learn about these things. You're going to learn about binary, hexadecimal, these numbers, and the foundation of computers. And you're going to use them a lot as you move forward with your studies. This is not something that we're learning for fun. This is something that's going to allow us to create much better applications. This is something that we have to learn about so that we know what's going on behind the scenes, and now we have full control over the applications that we're creating. And we're going to use these concepts a lot. If you're thinking that, hey, I've never dealt with binary before, I'm never going to deal with binary ever, actually that's not true. As a backend engineer, you're going to deal with binary a lot. And a few examples would be dealing with network requests. If a TCP request is coming in, an HTTP request, or if you want to send one of these requests, these are just zeros and ones. And in some cases, you have to directly deal with the zeros and ones that you are receiving or that you're sending. Or in encryption, if you want to encrypt something, you have to directly deal with these zeros and ones, or same thing for compression. Or file system, all the files, we've said this before many times, that files are just zeros and ones. Again, if you want to deal with files, which is something really common, you're going to deal with zeros and ones. Same thing with streams and a lot of other concepts. And we're going to get into a lot of these things in the course. So it's really important to learn about these things, and you're supposed to learn about them actually as a software engineer after maybe a few months of programming, or after 1 year of programming exposure or something like that. Again, if you just keep not getting into these things, you're really going to struggle as an engineer. So learning these things will allow you to create very high quality applications, will allow you to innovate new things. And as we move along with this course, you'll see that. You'll see that we're learning these core concepts, and these concepts will then allow us to create some applications with this Node.js that we wouldn't otherwise be able to create if we hadn't learned about these things. So these are opening new doors to us. We're just using the same thing. We would know how to use a specific module, for example, but we wouldn't really know how to use it effectively or how to create applications with that. But after we learn these concepts, you'll start to realize that, hey, this is a lot of new things that I can do now. I've never thought about them, but now I can do these things. So hopefully as you move with this course, you'll start to gradually appreciate how important it is to learn the fundamentals, not just about this course, in your whole career as a software engineer. Hopefully you'll start to realize that it's really much more important to spend time learning the fundamentals compared to learning these tools and frameworks and whatnot that keep coming in and become outdated in just a few years. These concepts will never become outdated. They have been the same thing for decades, ever since we had the computers, and they're going to be like this for decades to come. Okay, so this thing that you're learning right now is not something that's going to become outdated anytime soon. It's been like this for decades. So we're going to see a lot of hexadecimal and binary in this course because we're going to deal with binary a lot, and as a backend engineer, it's important to know how to do these things. Now, even if you have never even dealt with binary before, you probably have used hexadecimal before because it's really common in computing. Let's take a look at a few examples. Now, in the color codes in HTML or in CSS, if you have used them before, or even in Photoshop, this is what you would see. This is how we can represent a color. And again, this is just a binary number, but we're using hexadecimal to help us deal with that much better. Or maybe in URLs, if we have searched something for a character that is not in English, such as maybe Chinese or Japanese, those characters are getting converted into a hexadecimal code point. And we use different indicators for these ones. For example, for these color codes, we use a sharp sign, and in URL, we use a percentage sign to do that. Another example is in HTML. If you want to display some special Unicode characters, you would use hexadecimal code points, and the indicator is an %, and then sharp, and then X, and then the code point in hexadecimal. Now we're going to talk greatly about Unicode later in this section, but I just wanted to say that this hexadecimal numeric system that we're learning right now is really common. Even if you have never gonna deal with binary directly, you still would really deal with them at one point if you are developing software. So it's really common. And well, these are just some of the indicators that we use. Now, the most common indicator that we use, especially in Unix systems, is 0 and X. So we'll see this 0x a lot, and well, it's just something that I just wanted to point out. Again, as I said before, we use different indicators because we want to say that this thing that we're seeing, again, that color could also be 333 maybe, that is a hexadecimal number and not actually a decimal number. So again, same thing with all the other indicators. Alright, that's it about this video. Hopefully now you have a good understanding about hexadecimal, and again, we're going to use them a lot in this course. And now in the next video, we're going to pull up our programmer calculator and calculate some numbers and convert these numbers back and forth. Alright, so I'll see you in the next video.